Now we want to do more than just store the data. We want to turn it into information. And we do that by categorizing the data into different types. That's converting the data from unstructured to structured. Now we start with the data, and then the first hierarchy is to determine whether the data is qualitative or quantitative. Categorical would be qualitative and numerical would be quantitative. If it's numerical, then we need to determine whether it's going to be discrete or continuous. Discrete are whole numbers or integers, and continuous are decimal numbers. Once we make those determinations, then we can categorize the data as nominal, ordered, interval, or ratio. Nominal and ordered are qualitative data types. Nominal is named and not ordered. So for example, in GIS, if we have different land cover types, we have water and we have vegetation and maybe we have urbanization. Not one land cover is better than the other. They're just different. So they're named, not ordered. Ordered is where we're actually ordering things like low, medium, and high. High is greater than medium, which is greater than low. But we don't necessarily know what the differences are between them in measured values. Interval is when we're actually putting numeric quantitative numbers to our data. They're named, ordered, and measured, but have no absolute zero. And in GIS, for example, elevation is an example of an interval data type. Elevation, we have our highest elevations, which are, for example, Mount Everest, but they go not just to zero, but below zero. Zero is considered sea level, but there are places in the world, for example, in New Orleans, that are below sea level. So zero does not mean there's no elevation. It just is on a range of elevations. And then when we go below zero, we're actually at a different elevation below sea level. Ratio is data that is named, ordered, measured, and it also has an absolute zero. In GIS, for example, population is an example of a ratio data type. So you have places like New York City or Los Angeles that have a very large number. Then you have more rural locations that have smaller numbers, all the way to places, for example, in West Texas or in North Dakota that have zero. And zero means there are no people there. So whatever that data type is, when you have zero, it means there's none of it left. If we build on that, we can look at weather and understand how we categorize weather data utilizing this nominal, ordered, interval, ratio data types, or also known as NUAR is a good way to remember that. So with weather data, if we're just describing the weather, for example, via a forecast, it might be sunny, it might be rainy. That's an example of a nominal data type. The sunny is not more or less than the rainy, it's just different. But if we order that weather data, like for climate, hot, mild, and cool climates, now we're turning it into ordered data, in which the hot is hotter than the mild, and the mild is warmer than the cool, for example. When we look at an interval data type relative to weather, temperature is a really good example. Whether it's Celsius or Fahrenheit, 0 degrees does not mean there's no temperature. 0 degrees is a temperature. If you go outside, you're probably going to have to wear a coat because it's colder outside. And we actually have negative numbers. So the temperature is named, right? Celsius or Fahrenheit. It's ordered on a range, but it doesn't have an absolute zero. Now with ratio, wind speed is a good example of a weather phenomena that we can categorize as ratio data. So wind speed can be very fast, like in a hurricane, for example, you can have 100-mile-per-hour winds, or just on a breezy day, maybe it's 20-mile-an-hour winds, all the way down to zero. But when you get to zero, it means that there is no wind, and you can't have negative winds. So wind speed is a good example of a ratio data type. And again, what we're doing is we're moving all this weather information, these observations, from unstructured to structured data types. So here you can see in summary, unstructured data is considered dirty or raw. Often primary data is unstructured, and you're typically getting it from the source, or we call it source data. Structured data tends to be more cleaned, processed. It's often secondary data that we're accessing, and the data has already been assimilated. It's also a lot more usable at that point. So if we take our examples from the previous slides, weather station data, for example, is unstructured data, that kind of raw data coming from weather stations, every hour, 24 hours a day, for example. But if we analyze and assimilate that data and we create daily min-max temperature values for Austin, that's structured data. Census forms are an example. If I go into the field, whether it's a paper or an electronic, and I start collecting data, that's unstructured primary data. But when I start assimilating that data for geographic regions, we'll say Travis County, then it becomes structured data. credit card purchase as well. Every day, everybody's swiping their credit cards everywhere. The data is just floating out there in space. But what we're finding are different organizations are collecting that data and then turning it into information, into structured data that they can analyze to understand things about purchasing patterns, like your purchasing history.